Today we're in section 4.1, starting chapter 4 already. Isn't that crazy? Chapter 4 already? All right, so we are in chapter 4. Today we're learning about a method called prime factorization, where we take a number and we break it down into its prime factors. The first thing you need to know is your terms. What is a factor? What is a prime number? And what is a composite number? A factor is a number that is evenly divisible by another number. It's a number that evenly goes into it. A prime number is a number whose only factors are 1 in the number itself. And a composite number has other factors other than those numbers. So any other factor, if any other factor is present, then it means it's a composite number. So we're starting basic. I want to list the factors of each number. So I start with 1 in the number itself, and I'm going to increase. I'm just going to keep going up. I'm going to go 1, 2, 3, 4, 5, 6, all the way up until my numbers start repeating. So I know that 1 times 36, yes, is 36. Does 2 go into 36? Yes. Yes, how many times? 18. Okay, now here's where your calculators will be helpful. You might know, yes, 36 is an even number, so I know that 2 is a factor, but I'm not sure how many times. Use your calculator to find that. Use your calculator to find that. 2 times 18. What about 3? 3 times what? 3 times 12. 3 times 12. What about 4? What about 4? 4 times 9. 5? Nope. 6? Yes, 6 times 6. 7? Nope. 8? Nope. 9? Yes. 9 times 4. Except now, didn't I already write that? Didn't I already write that? 4 times 9? So as soon as my factors start repeating, okay, I don't need that one because I already wrote 4 times 9. I know that I've completed my list of factors. And now I'm just going to list them out. I'm going to start with my smallest number, my 1, and I'm just going to write my numbers straight down. Okay, so it's going to look like this. 1, 2, 3, 4, 6. And now I'm going to write them up this way. I'm going to list them. 9, 12, 18, and 36. And I'm done. All right, so it's like I go down one row and then up the next row, and then I've listed. That way I make sure that I don't forget any. I've listed all of the factors of this number. Now, notice how many times did I write a 6? Just once. Okay, even though I had 6 times 6, I had it twice. I only need to write it once in my prime factorization. Or I'm sorry, in my factorization. All right, so on 72, I want you to break down 72 into all of its factors. All right, so for 72, we list them out. 1, 2, 3, 4, 6, 8, and 9. Now look, 8 times 9 is 72. 9 times 8 is 72. That's when it repeats. Did you cut it off? Did you cut it off there? All right, and now I just list out my factors. Who got it right? Who got it right? Raise your hands, high and proud. Very good. Awesome. Good job. All right, so listing factors. Now, I'm going to teach you today 2 ways of finding prime factorization. Before we do that, I always forget about this example. In example 2, we're identifying prime and composite numbers. What does it want to know? It wants to know, is this number prime or composite, and why? The why is important. So you're not just saying eeny, meeny, miny, mo, okay, it's prime. You're actually giving me a reason why you think that it's prime or composite. So, here's what your reason looks like. Is 81 prime or composite? What do you think? Does it have any other factors between 1 and 81? It is composite. So, my proof or my explanation is going to be to list at least one other factor. Now, there might be more than one, but just one other factor makes it composite, so I only need one. It's composite because what number is another factor? 9 is a factor. What other number is a factor? Nope. 3 is a factor, 27 is a factor. Any of those would be acceptable reasons. I said 3. You can say 9. You can say 27. It doesn't matter as long as you give me one other factor. What about 17? Prime or composite? Prime. Why? Okay, so when it's prime, the reason will always be the same because the only factors are 1 and 17. Okay? The reason will always be the same. You just say only factors are 1 and the number itself. That's it. All right, so I want you to do 51 and 120. Are those two numbers prime or composite, and why? All right, is 51 prime or composite? It is, what? Composite. Why? What's another factor? 3 is a factor. 17 is a factor. All right, 51 is one that trips people up every year because, honestly, it kind of looks like it would be prime, right? But you got to remember, 3 goes into it. What about 120? Oh, it is so composite. There are so many factors. So many factors. 5, 2, 4, 10, 20. Oh, goodness. 6. All right. Any of those would be acceptable answers. Just give me one. One other factor makes it composite. All right. Now let's talk prime factorization. Now, here's what I'm doing. I am taking a composite number. Does everybody agree that these two numbers are composite? Everybody agree? I'm taking a composite number and I am breaking it down into its prime factors or prime components. So what does that mean? Think of it like a puzzle. So here I have my complete puzzle. And then I can break that puzzle apart into its pieces, but could I put that puzzle right back together? Right? I could put it right back together. So 54, that's my complete puzzle. Now I'm going to break it down into its pieces, but it doesn't mean that I change the value. It just means that I'm showing the factors that are inside that number. Does that make sense? Okay, so a factor tree. Here's my advice on a factor tree. Does it make a lot of sense to start a factor tree like this? 1 times 54. Why? Because one side is so lopsided, right? It's so uneven. So my advice to you would be to choose two factors that are very close together in their value. Okay, 1 and 54 makes it really lopsided. 2 and 27, still very lopsided. Can anybody think of two factors that are pretty close together in value?
6 and 9.
6 and 9. Okay, 6 and 9 would be the numbers that I would use also. All right, so let me just jump over screens here really quick. All right, so I'm going to choose 6 and 9. Very good. All right, now I'm going to keep breaking down the numbers until I have only prime components left, or only prime factors. Well, is 6 prime? No, it's not prime. You keep saying that. 6 is not prime. More than just 1 and 6 goes into 6. 2 goes into 6. 3 goes into 6. All right, these numbers are not prime. I can break 6 down into 2 times 3. I can break 9 down into what? 3 times 3. Notice that I do not have a multiplication sign here. Do you think you need one? No. Yes, you do. Because here's what you're saying. You're saying that all these numbers multiplied together are going to equal 54. Okay? So do it in your calculator. What is 2 times 3 times 3 times 3? All right, but we're not done. This isn't the finished product because now I need to write my repeated prime factors as powers in my prime factorization. Are there any prime factors that are repeating? Any prime factors repeating?
3.
Yes, 3. How many times?
3.
So 2 times 3 to the third power is how I would write it. I write it in order least to greatest. 2 is the smallest, so it comes first, times 3 to the third power because it repeats 3 times in my prime factorization. All right, I want you to do 48 the exact same way. All right, so now I'm going to break down 48. What factors did you use? Which factors did you start with?
6 and 8.
6 and 8. Anybody use anything different? There's one other one that would be
12.
pretty close. 12 and 4. You could do 12 and 4. I did 6 and 8. All right, so I break down 6. Is 6 prime? No. No, 6 is not prime. 2 and 3 are its factors. And now I break down 8 to 2 and 4. Okay, so I'm done. This is my prime factorization, right? Wait, I had 2, 3, and 2 are prime numbers. But 4 is not. 4 is not. I still need to break down 4. Whoops, I didn't mean to do all of those. I need to break down 4. I just bring these down, and then I break down my 4, and now I just write my repeated prime factors as powers, and I'm done. Who got it right? Who got it right? Raise your hands. Good job. Okay. If you got it wrong, fix it. Try to figure out what you did wrong. Okay, so that's factor trees. Now I want to show you another way that you can do the prime factorization. In my opinion, this way is maybe a little easier. It takes a little less brain power, all right? And it's definitely practical when you have really big numbers like 612. It would be, would y'all agree, difficult for me to figure out two factors that are kind of close in value of 612? That would be a little harder than doing 24, right? Okay, so there's another method that I can use, and I could use it even for the small numbers. It's called upside down division. With upside down division, here's my only rule. I must divide by a prime number. So you've got to know what the prime numbers are. If you divide by a composite number, your answer will be wrong. So you can only divide by prime numbers, but as long as you do that, it should work out just fine. So let's look at the number 144. We said earlier in class that any even number has a factor of what? 2. Has a factor of 2. So would you agree that 144 is an even number? Yes, it is. So 2 could be a factor. Now, what's a way that I could test right off the bat? What's an easy way that I could see if 3 is a factor using mental math? How could I see that 3 is a factor? You did learn this last year in elementary. How do I know that 3 is a factor? It is. But how do I know that? Anybody remember what we do? So I look at the digits of 144 and I add them together. What is 1 plus 4? 5. What is 5 plus 4? 9. Does 3 go into 9? Yes. So that means that 3 is a factor also. So again, you could start this using a couple different factors. All right? But as long as they're prime, you'll still end up with the same answer. So I'm going to start with a 2. 2 goes into 144 how many times? How many? You can use your calculators. 72. Now, still an even number, so I can still use a 2. 2 goes into 72 how many times? 36. 2 goes into 36 how many times? 18. Still an even number, so I can still use a 2. 2 goes into 18 9 times. Oh wait, 2 doesn't go into 9, so I'm done. Is 9 prime? No, I can still divide by, as long as it's a prime number, another prime number. And when I have a prime number on the bottom, I know that I have completed my prime factorization. So 3 is prime, I know I'm done. But I need to now list them, or I need to now write my repeated prime factors as powers. 2 repeats itself how many times? 4 times. 2 to the 4th times 3 to the 2nd power. Done. All right, I want you to do the same thing to 612. All right, so starting, what number did you start by dividing by? 6? Can I divide by a 6?
Yeah.
Why can't I divide by a 6? Because it's not prime, right? I have to divide by a prime number, like 2, because it's an even number. 2 goes into 612, 306. 2 goes into 306, 153. Oh, 2 doesn't go into 153, so I'm done? No? Because a 3 goes into 153. 51 times. Is 51 prime? Is it? Nope. What goes into 51? 3 again. And then 17. Is 17 prime? Yes, it is. So I know that I'm done. 2 to the what? 2nd power times 3 to the 2nd power times 17. And guys, I want you to multiply that in your calculators. What is 2 squared times 3 squared times 17? Use your exponent button. 2 squared times 3 squared times 17. What do you get? In your calculators. 612. So you see, all I did was break down 612 into its prime factors, or its prime pieces. I can put it all back together just as easy as I can just multiply them together. Does that make sense? I didn't change the number. All right? I didn't change its value. I just broke it down into its prime components. Upside down division, by far my favorite way of doing it. All right, so now I want you to test the solution or find the solution and then tell whether or not it's prime or composite. So here I'm substituting a value for the variable. 6 goes in for x. All right, so I substitute 6 for x. I need to multiply and then add. And then tell whether or not that number is prime or composite. There it is. All right, so substitute 36 plus 1. What mistake did I make? It's 3. What operation is shown by a number and a variable next to each other? Multiplication. So when I plug in the 6, I need what around the 6? I got to have parentheses. Okay, parentheses around my 6. Now I get 19. Is 19 a prime or a composite number? It is composite. Or, no, it's not composite. It's prime. It's prime. Why is it prime? Because no other number besides 1 in the number itself goes into 19. All right, I want you to test r to the third plus 17 when r equals 4. All right, guys, so when I substitute and solve, I get 81, and 81 is a composite number. Who got it right? Who got it right? Awesome. Good job, guys. All right, and I believe that is everything you need to know for 4.1.